Hi guys, welcome to my channel. In this video, we're going to discuss about describes principal roots and tells whether they are rational or irrational. Then, determines between what two integers the square root of a number is. Okay, the objective, we have two objectives in this lesson. After watching the video, you will be able to describe principal roots and tells whether they are rational or irrational. Then you will be able to determine between what two integers the square root of a number is. Okay, what is square roots? Squaring the number means multiplying the number by itself. Okay, we have here the square of 3. Okay, so written as 3 squared. So this statement, guys, is being read as 3 squared, meaning the base 3 is being multiplied by itself twice. So 3 times 3, that is equal to 9, positive 9. Then we have also here the square of negative 3. So if we're going to multiply the base, which is negative 3, by itself twice, that is so the product still positive 9. So guys, you have noticed here, guys, the result are the same. So meaning to say, once we are dealing with square roots, it involves positive and negative values, right? So since 9 is the result of squaring a number, 9 is an example of perfect square. Alright? So we have here first 8 perfect squares examples from 1 up to 64. So these numbers are being called perfect square. It's because these are the result after multiplying a number by itself. Okay, so this is in factored form. So 1 here is being multiplied by itself. Okay, or that is 1 squared. The result is 1. Now if we are going to extract the square root of 1, that is equal to 1, because this is the number multiplied by itself to obtain 1. So with 4, so this is the result or the product after multiplying 2 by itself, or that is 2 squared. Okay, now if we're going to extract the square root of 4, well, that is 2, because 2 is this number multiplying by itself, the result is 4. So with 9, 16, 25 until 64. Alright, so guys, in order for you to have your own guide, I want you to continue the table, let's say 1 up to 50, 1 up to 15. Okay, so if you have noticed here, the numbers are consecutive. So just continue so that you will have your own guide. And it is easy for you to determine the square root of a perfect square numbers. Alright? Okay, in symbol, guys. Okay, so this is the symbol for square root. In here is what we call radicand. Okay, in here represent by any real numbers, okay, or any integers. Then this one is what we call radical, and this one right over here is what we call index. Okay, guys, the index of this symbol, if we are talking about square root, that is equal to 2. Okay, and that is imaginary, so we do not need to write 2 here. That is imaginary. Alright, so example on how to determine the square roots of a certain number. Okay, so in this case we have two problems. Find the indicated square root of 49, then square root of 121. So let us first with square root of 49. Okay, if you could still remember in our previous slide, under the first 8 perfect square numbers, 49 is included. So meaning to say 49 is a perfect square number. So the square root of 49, that is equal to 7, because 49 is the product after multiplying 7 by itself. Alright? Then we have here square root of 121. Okay? So the square root of 121 is 11. So since the square root is a whole number, meaning to say that 121 is a perfect square number. Right? So 121 is the result after multiplying 11 by itself. So that is 11 squared. Alright? So it is easy to extract square root, guys, if we already familiarize the perfect square numbers. Alright, now another way in extracting square root, especially if you are dealing with numbers that is not a perfect square number. Okay, so there are several steps to follow. So number one, of course, we need to estimate first. So our given here is 44. So 44 is not a perfect square number. So we cannot extract right away the square root of this. So we need to apply this following steps. So first one, estimate square root of 44. Okay, so by estimating, we need to figure out of a perfect square number closest to 44, no, and greater than 44, and that is 49. So if we're going to extract square root of 49, okay, so this is the result after approximation from step 1. So if we're going to extract the square root of 49, that is equal to 7. Okay, so meaning square root of 44 is approximately 7. Right? Now, step 2, divide the radicand by the result of step. Okay, so divide the radicand by the result of step number 1. Okay, so square root of 44 will be divided by our approximated number, and that is 7. So if we're going to divide this one, the result is 6.29. Alright? And then for step 3, get the average of the result of step 1 and 2. So we need to add the result from step 1 and 2. Then we will divide it by 2. Okay? So this is the result from step 1. Upon approximating, then this is the result from step 2 after dividing the radicand by this number. And then in step 3, we're going to add this 2. So our divisor here, why 2? It's because we are adding 2 values. Alright? So we're going to simplify this problem. The result is 6.645. So this is now the average after adding step 1 and step 2. Right? So if you are going to analyze this value, it is very close to 7. We're going to round this off. Right? Okay, we need to take note of this, guys. The square roots of negative real numbers are not real numbers. Right? Then, number like square root of negative 4, okay, are imaginary numbers. Okay, in this video, guys, we're not going to discuss about imaginary numbers. Right? So there's another lesson for that. Okay, the square root of 0 is 0. And the square root of positive integer is either rational or irrational. Alright? So later on, we're going to discuss when the square root becomes rational or when it becomes irrational. Okay, so rational and irrational. If the radicand is a perfect square, then the square root is rational. Okay, take note of this, guys. If the radicand is a perfect square, of course, the result is a whole number. And a whole number that is rational. Alright? So, if it is not rational, so otherwise it is irrational. So, irrational numbers like square root of 2, square root of 3, square root of 5, square root of 7, etc. When these numbers is being transformed into decimal numbers, the decimal numbers are non-terminating and non-repeating decimals. Okay, when we see non-terminating, the decimal numbers are continuous. There is no ending. Alright? Then when we see non-repeating decimals, there is no digit that repeat itself infinitely. Alright? So this is our basis for us to conclude that the square root is irrational. Alright? But I want to emphasize also, guys, that not all decimal numbers are irrational. Okay? Now, if the decimal numbers are terminating, meaning it ends, and there is no digit that repeat itself, so we can consider that one as rational. Alright? So again, not all decimal numbers are irrational. Okay, this will be our basis for us to conclude that the values are irrational. Alright? I hope you get it, guys. Okay, example number 2. So determine whether each square root is rational or irrational. Okay, so we have two problems here. First, deal with square root of 169. Alright? Excuse me. Square root of 169 is a perfect square. Okay? So therefore, it is rational. Right? So, because 169 is the product or the result after multiplying 13 by itself. Okay? So again, 169 is a perfect square number. So therefore, this is rational. Next, we have here square root of 41. Okay? So, when we're going to extract the square root of 41, it will give us the value equal to 6.4031243 and so on. So, meaning the value or the decimal numbers are non-terminating. So, there is no ending. Right? So, meaning to say that square root of 41 is not a perfect square number. Right? So, therefore, since it is not a perfect square, so therefore, square root of 41 is irrational. Alright? Okay, guys. So, I have prepared an exercises for you. So, if you want to answer this one, just take a screenshot and then write your answers in the comment sections. Okay? So, this is all about part 1 of our lesson. Okay, now we will proceed to the next one, part of this lesson. Okay, so this time we're going to discuss how to determine two rational numbers between which each square root lies. Okay, so we have here two problems. Okay, let us deal with square root of 58. So square root of 58, guys, is not a perfect square number. Okay, so how are we going to know if which this value lies between two rational numbers? Alright, so let me show you the solution. So the radicand is between perfect squares 49 and 64. So in this solution, guys, it tells us that we must think of a perfect square number closest to 58 and greater than 58, and also closest to 58 but less than 58. Okay, so the perfect square number less than 58 is 49, and the closest to 58 perfect square number which is greater than 58, that is 64. Alright, so meaning square root of 58 is in between square root of 49 and square root of 64. Now, our task is to look for the two rational numbers. So, after doing this, we need to extract the square root of 64 and the square root of 49. And the square root of 49, that is 7, and the square root of 64, that is 8. So you have noticed, guys, here that the two rational numbers are consecutive. So if you already found one rational number, so automatically, for example, 7 here, so automatically, the other one is 8. Okay? So this is very simple, guys. Okay, I hope you got it. Alright? So in our next example, the radical is fraction. Okay? So square root of 5 over 8 lies between 3/4 and 1. Okay, let us see the solutions. Okay, first step, we need to make the denominator a perfect square number. So we must think of a number or a perfect square number closest to 8. Right? So maybe we can think of 9, but there is no such number that to multiply 8 to obtain 9. So 9 is not applicable. So next to 9 is 16. Okay? So to make 8 equal to 16, so we must multiply 8 by 2. Okay? Then, if we multiply the denominator by 2, we must also multiply the numerator by 2. Okay? So, after multiplying, this is now the result. Square root of 10 over square root of 16. So, this value now, we are going to use to look for the two rational numbers. So, you have noticed here that the denominator is now a perfect square number. Okay, now, to look for the two rational numbers, the new 10 here will be our basis, okay, in order to determine what the two rational numbers is, or are, rather. Alright, so, again, the numerator, which is 10, will be our basis to look for the other two numbers, okay, in the numerator. Okay, here, we must think of a perfect square, two perfect square numbers closest to 10, but greater and less than 10. Alright? So the perfect square number greater than 10 is 16. Alright? Then, the perfect square number closest to 10 but less than 10, that is 9. Alright? So then we just copy the denominator. Alright? Okay, now after doing this, we need to extract the square root of these two rational numbers. Alright? So, square root of 9 over 16 and square root of 16 over 16. Okay, that is, okay, the square root of 9 over 16 is 3/4 and the square root of 16 over 16 is 1. Okay? Because 16 over 16, that is 1. The square root of 1 is 1. So, therefore, square root of 5 over 8 lies between 3/4 and 1. Alright? So, it's little difficult, guys, if our radicand is fraction. Okay? So, you need to practice this one. Right? Okay. So, that's the end of part 2. So, I have prepared an exercises for you regarding part 2 of our lesson. Okay? So, if you want to answer these problems, just take a screenshot, then write your answers in the comment section. Alright, guys? So, thank you for watching, guys, and I hope you have learned something. And if you like the video, please subscribe, like, then hit that notification button so that you will be notified in my next video. Right? So guys, if you want to master this lesson, my advice to you is keep practicing. Alright? Keep practicing. Okay, so this is Sir Ponting saying practice makes perfect. Bye!